Imagine giving a child a simple digital task. Ask them to find the exact placement for the number 45 on a blank horizontal line spanning from 0 to 100. This diagram illustrates a horizontal line marked from 0 to 100. When faced with this exact scenario, a child who lacks number sense will often drag the marker and drop it in the dead center. This happens because their brain is treating the number 45 as a disconnected symbol. They don't yet see it as a proportional magnitude with a specific physical location. In reality, 45 shouldn't sit in the middle. It belongs precisely here, just shy of the halfway mark. Failing this quick exercise suggests that for this child, 45 is just a shape on a screen, rather than a physical distance they can visualize. The ability to instinctively look at an amount and gauge its size in physical space is known as number sense. Think about estimating the volume of jelly beans rapidly filling a clear glass jar. Without an internal spatial gauge, looking at that jar tells the child very little. They have no mental scale to compare the volume against. This cognitive gap affects everyday tasks. A child might struggle to estimate the distance to the end of a street, or figure out how to measure a quarter cup of flour for a recipe. Even the concept of time becomes confusing. If a child cannot estimate mathematical progression, 5 minutes and 50 minutes can feel indistinguishable. Numbers remain static symbols on a page, disconnected from the physical logic of the world. Spatial math provides the cognitive architecture that links mathematical value to actual physical distance. This diagram demonstrates that concept in action. A child's brain needs to construct a physical relationship between numbers to comprehend scale, like seeing a geometric block labeled 10 physically expanding to represent a volume of 45, relative to a boundary of 100. Actively visualizing these distances trains the brain to recognize the specific physical relationships between different amounts. This process relies on visual mapping. It is a distinct neurological process from counting out loud or reciting memorized multiplication tables. Spatial math provides the framework necessary to give abstract numbers physical weight and dimension in the human mind. The BornFab app uses a digital game called Numberline to mechanize the creation of this spatial awareness. This interface shows how it works. A user places a marker on a digital slider, forcing them to estimate mathematical distance on a blank line. If they miss the marker flashes red and then slides to the correct position. The repeated action of dragging and adjusting that marker forces the brain to internalize those proportional relationships through constant visual feedback. Scholastic education experts view this specific mental construct, the mental number line, as a primary building block for more complex arithmetic later on. A continuous digital microaction like this systematically wires a developing brain to understand proportional reality. A straight 0 to 60 number line bends into a circle to form an analog clock. This represents the mental number line overlaying the real world. Reading it is an act of spatial math. You are interpreting the proportional division of a circle. That same internal spatial map applies to physical tools, allowing them to use a ruler, measure a physical room, or read a geographical map. The mental number line provides the essential bridge between digital abstraction and independent daily life skills. We can transform daily screen time into targeted cognitive training. You can evaluate your household's current digital habits by taking the BornFab 30-second screen time diagnostic quiz. BornFab also provides a free, downloadable family screen time contract to set clear, research-backed boundaries that the whole family agrees on. Start a 7-day free trial of BornFab today to begin constructing your child's spatial math foundations.